In this video, we're going to continue our discussion with graphing quadratic functions. So let's take a look at the next example. I want to calculate the vertex first, but before we do that, we must be able to determine the equation for the axis of symmetry. So let's write the formula to write the equation for the axis of symmetry. X equal to negative b over 2a, so let's write so the axis of symmetry is x equal to a half. Now, I need to plug that into this function. When I simplify, I get this. So we get 0. So then the vertex is 1/2 comma 0. All right, next I want to calculate the intercepts. Let's do the y-intercept first. Remember, the y-intercept is when x is 0. So when I plug in 0, it is 0 plus 0 minus 1 is negative 1. So the y-intercept as an ordered pair is 0, negative 1. So now I want to calculate the x-intercept. Remember, that is when g of x is equal to 0. We're going to divide out a negative 1 from every single term. This is factorable. Since the factors are the same, I'm just going to set one of the factors that contain a variable equal to 0. And writing that as an ordered pair, that's 1/2 comma 0. Now, the x-intercept is exactly the same ordered pair as the vertex. So let's plot then the vertex and the y-intercept with the equation of the axis of symmetry. So again, the points are in black, and the red dotted line is the equation of the axis of symmetry. Now again, I should be able to get one other point. This point, the y-intercept, is 1/2 to the left of the equation of the axis of the symmetry. So if I go 1/2 to the right, I get this particular point here. So again, this is my free point. So in this case, the ordered pair for the free point is 1, negative 1. Connect the dots, and we get a graph of our quadratic function. Now, notice the leading coefficient here is negative, and the parabola is opening downwards. So, if a is less than 0, the parabola will open downwards. If the leading coefficient is greater than 0, the parabola will open upwards. Okay, one other example I want to take a look at. Notice the leading coefficient is positive, so I know the parabola is going to open upwards. So first thing I want to do is to determine what my vertex is. But before I do that, I need to figure out what the equation of the axis of symmetry is. So let's write that out. So now we know that will be negative 4 over 2 times 1, which is negative 2. So the equation for the axis of symmetry is negative 2. So now plug that negative 2 into the function. And it simplifies to this. So the vertex is negative 2, negative 2. Now, let's calculate the intercepts. So again, I'm going to do the y-intercept first. Again, that's when x is 0. So h of 0, that's 0 plus 2, that's 2. So the y-intercept is 0, 2. Now, let's calculate the x-intercept. Remember, that's when h of x equals 0. So now notice this is not factorable, so I'm going to complete the square here. So I'm going to take half of 4, which is 2, and 2 squared is equal to 4. So I'm going to rewrite. So remember, I'm going to put the 4 here and minus 4 here. Factor the trinomial. And 2 minus 4 is negative 2. So I'm going to add 2. Take the square root of both sides. Remember, that's plus or minus. And then subtract 2. So I have two solutions here. Negative 2 plus the square root of 2 is equal to x. And negative 2 minus the square root of 2 is equal to x. Now, let's use a calculator to figure out what the approximation for negative 2 plus 2 is, and negative 2 minus the square root of 2 is going to be. Well, negative 2 plus the square root of 2 is about negative 6/10, so I wrote that as an ordered pair. And negative 2 minus the square root of 2 is approximately negative 3 4/10, which I wrote as an ordered pair here. So now what I want to do is I want to plot all of these points on the coordinate plane with the equation of the axis of symmetry. Okay, so all the points are plotted and the equation of the axis of symmetry is shown. So again, look at the y-intercept. It is 1, 2 away from the axis of symmetry to the right. So now I want to go 2 to the left from the axis of symmetry here. 1, 2. And this point right there is now my free point, which in this case is negative 4, 2. So now connect the dots. And now our quadratic function is graphed.